Alright, so we're looking at section 8.2, numbers 1 through 3 in your practice workbook, and we're going to be asked to find the measure of angle D. We're told that ABCD is a parallelogram, and we're asked to find the measure of angle D. So, I'm going to go ahead and circle angle D, and put a little symbol on there saying that's the angle we're looking for. Now, one new thing you need to know about quadrilaterals is that for a quadrilateral, all the interior angles add to 360 degrees. I've written that green below. And we're going to go ahead and use what we know about parallelograms to find the measure of angle D. What we know so far is that the opposite angles are congruent. So if A is 30 degrees, that means that C is also 30 degrees. So we know A, we know C. Guess what? D and B are going to be the same because they're opposite angles, and opposite angles in a quadrilateral are congruent. So if I label B x and I label dx, that's the measure we're trying to find, I can set up an equation. 30 degrees plus, that's the measure of angle C, 30 degrees for the measure of angle A, plus x for the measure of angle D, plus x for the measure of angle B is equal to 360 degrees. When we simplify this side, we get 60 plus x times x plus x rather is 2x is equal to 360 degrees. So 60 plus 2x equals 360. We can solve that by subtracting 60 from both sides. Remember, we always subtract before we multiply or divide, giving us 2x is equal to 300 degrees. Divide both sides by 2, and we get x is equal to 150 degrees. So that means the measure of angle D is equal to 150 degrees. So now we're going to be looking at numbers 4 through 9. Find x and y, and we're told that HIJK, which we have the picture of here, is a parallelogram. Well, we know the property parallelogram tells us that opposite sides are congruent, so that means that KJ is going to be congruent to the side that's opposite or across from it, HI. Well, congruent means, in this case, equal measure. The lengths of these segments is going to be equal. So I can write 3x minus 4 is equal to 2. Since I've set up an equation, I can solve it, add 4 to both sides, and I get 3x is equal to 6. Divide both sides by 3, and I get x is equal to 2. Well, great. That's how I solve for x. I bet you can figure out how we're going to solve for y. It's very similar. Y minus 7 is across from the side that says 9. Guess what? That means y minus 7 is equal to 9 because opposite sides are congruent. We can solve for y by adding 7 to both sides, giving us y is equal to 16. And there you go. We solved for x and y using the property parallelograms that tells us opposite sides are congruent. So we're going to look at a slightly different one. Suppose we're asked to find the measure of x. And you notice that 2x minus 4 and 88 are across from each other. Well, the good news is opposite angles, angles that are across from one another, are congruent in a parallelogram. So that means that 2x minus 4 is equal to 88. We can solve x by adding 4 to both sides. Remember, we add and subtract before multiplying and dividing. Leaving us with 2x, because those cross out, is equal to 88 plus 4 is 92. We divide both sides by 2, and we get x is equal to 46. And there you go, we solve for x. So our last type of problem for 4 through 9 is, suppose we're given a parallelogram that looks like this. Now look at the diagonals. We know that in a parallelogram, the diagonals bisect each other. That means they cut each other in half, which, for our purposes, when we're solving for x and y, you'll notice that 8 and x minus 5 are the same length. Because that length has been bisected, it cut it in half, so the lengths are the same. This means that x minus 5 is equal to 8. We can solve for x by adding 5 to both sides, giving us x is equal to 13, and we've solved for x. Good news is 2y and 4y minus 10 follows the same pattern. Since the diagonals bisect each other, that means this length is the same as this one. So 2y is going to be equal to 4y minus 10. We can subtract 4y from both sides because we have to get all of the y's on the same side, giving us negative 2y is equal to negative 10. 4y, negative 4y cancel. Divide both sides by negative 2, and we get y is equal to 5. Now we're on to our last type of problem, which is going to ask us to find all of the angles for the parallelogram shown. Now we're going to have to pull information from lessons in the first semester. Let's look at some of those properties of lines and angles that we learned then. First one, vertical angles, those angles that make a V with each other, such as this 120 degrees, which I'm outlining in blue, and the angle above it are congruent because they're vertical angles. So this angle is 120 degrees. Well, if you'll also remember, any two angles that are next to each other that form a line, such as 120, all the way over to this angle right here, add up to 180 degrees. 120 plus what equals 180? Well, 120 plus 60 equals 180. So we know that that angle right here is 60 degrees. Well, since this is a vertical angle with the other angle across from it, this angle is also 60 degrees. And in a very short time, we found 3 missing angles inside of this parallelogram. The other information is going to require us to remember that a parallelogram tells us opposite sides are parallel. Remember those little arrows? Mean that the sides are parallel. So if this is 30 degrees right here, I'm going to circle the 30 degree measure, that means the angle that is an alternate interior angle from it is also 30 degrees. So this angle is 30 degrees. So if this one's 50, the alternate interior angle from this 50 degrees is also 50 degrees. Now we have one last property to look at in order to find those missing angles, which I'm going to put in green. We need to find this one, this one, this one, and this one. Now they're not all the same. We know that these two are the same because they're alternate interior, and we know that this one and this one are the same because they're also alternate interior. Well, the good news is we know one last property that tells us all the angles inside of a triangle add up to 180 degrees. So let me outline one of our triangles to give you the idea in red. So here's our triangle right here. That means that 120 plus 50 plus some unknown angle is 180 degrees. 120 plus 50 plus 10 is 180. Well, if this degree measure is 10, that means the alternate interior is also 10 degrees. And we can do the same sort of thing with another one of the triangles. So 30 plus 60 is 90, which means this angle right here must be 90 degrees. And the alternate interior angle from that must also be 90 degrees.